See, myself, Ramesh Naik, I have qualified Gpat 3 times and I have completed my M.Pharm from IIT BHU Varanasi. So today's topic is aromaticity. This topic comes under the organic chemistry and very important for the Gpat and NIPER examination. See, before knowing see how this aromaticity, the name can be derived means, see, before knowing the chemical properties of the compounds, those compounds or the molecules can be classified based on their physical property. Order is a order is a one kind of physical property. See, order also we can call as a aroma. Aroma also we can call as a order. See, before knowing the chemical properties of the molecules can be classified based on their physical property, that is order or aroma. See, aromatic compounds. What is the meaning of aromatic compounds? See, aromatic compounds are the organic compounds. These organic compounds having the chemistry similar as that of benzene. These organic compounds having chemistry similar as that of benzenes, hence we can call as aromatic compounds. Next, see, under the aromaticity, there is a three kinds of compounds will be there. One is aromatic compound, anti-aromatic compound. Next one is a non-aromatic compound. See, what are the basic characteristics of aromatic compounds are? Number one is cyclic. The molecule should be in a cyclic nature. Next, the molecule should be contains carbon atom. Those carbon atoms should be double bonded. Nothing but sp2 hybridized carbon atoms. Next, delocalization of electrons also possible. The molecules also need to exhibit delocalization of electron, nothing but resonance. The molecule need to exhibit the property of resonance. Next one is the molecule having the property of planar. Planar, nothing but the molecule should be present either in X plane or in the Y or in the Z plane. Next, very important property, the molecule should exhibit the Huckel's rule. What is this Huckel rule? Nothing but 4n plus 2 is equals to number of pi electrons. Next, when it comes to the stability of aromatic compounds, these are highly stable. Example is benzene. See why these aromatic compounds are highly stable? Nothing but because of continuous movement of the electrons, because of continuous movement of the electrons within these molecules, the molecular energies get reduced. The energy within this molecule is get reduced, but the stability of the molecule is get improved or increased. Next, anti-aromatic compounds. Anti-aromatic compounds having the property of cyclic nature. sp2 hybridized carbon atom, nothing but double bonded carbon atom. Delocalization of electron, nothing but resonance. The molecule also need to exhibit the resonance and the planarity. The molecule also should be in the planar structure. Next, the molecule need to follow the 4n rule. 4n is equals to number of pi electrons. Next one is the molecular highly unstable. What about the stability of anti-aromatic compound means the compounds are highly unstable. Example is cyclobutadiene. Next, non-aromatic compounds. These are acyclic in nature. The compounds are sp3 hybridized carbon atom, nothing but single bonded carbon atom. No delocalization of electron, nothing but no resonance can be exhibited. No planar structure. Next one is it do not obey Huckel rule or 4n rule. What about the stability of non-aromatic compound? Nothing but intermediate stability. The example is cyclopropene. Example is cyclopropene. So these are the basic characteristics of aromatic, anti-aromatic and non-aromatic compounds. Next, when it comes to the compounds, then how we can determine whether the compound is aromatic, anti-aromatic or non-aromatic. So for example, I have considered here cyclopropene. See, I will tell the cyclopropene as a non-aromatic compound. Why means here The carbon is single bonded. Single bonded nothing but it is sp3 hybridized carbon atom. The carbon atom is sp3 hybridized carbon atom. Because of sp3 hybridization, the resonance may not be possible. When the carbon atom is in sp3 hybridization, resonance is not possible. Hence, I can classify the cyclopropene under the non-aromatic compound. Then comes to the cyclopropenyl anion. Cyclopropenyl anion. See, when it comes to the cyclopropenyl anion, we need to apply the 4n plus 2 rule. That is 4n plus 2 is equals to how many electrons, pi electrons are there? See, this is a pi bond. Then we people are getting doubt whether these are the extra pair of electrons. These are also comes under pi electrons. Pi means this electron will come here and form pi bond. This electron will move to this carbon. Hence, we need to consider the number of pi electrons are 4. Then 4n is equals to 4 minus 2. Then we will get 4n is equals to 2. N is equals to 2 by 4. That is 1 by 2. That is 0.5. Nothing but the compound cannot be considered as a aromatic compound because the value is in decimals. Next, apply the 4n rule. That is 4n is equals to 4. N is equals to 4 by 4. That is n is equals to 1. When the n is equals to 1, that is the integer, then the compound is anti-aromatic. So the cyclopropenyl anion is anti-aromatic in nature. Next comes to the cyclopropenyl cation. Cyclopropenyl cation is, now we need to identify, apply the 4n plus 2 rule, that is number of electrons. Pi electrons are only 2. Then 2 minus 2, that is a 0. N is equals to 0 by 4, that is n is integer. When the n is integer, then the compound is aromatic compound. If we people are applying 4n rule, then we will get 0.5. That is may not be considered as a anti-aromatic compound. So now cyclopropene is non-aromatic nature. Next, cyclopropenyl anion is anti-aromatic. Next, cyclopropenyl cation is aromatic compound. Next comes to the cyclopentadiene. Cyclopentadiene also non-aromatic compound. Why it is non-aromatic? It contains sp3 hybridized carbon atom. No resonance is possible. Hence, it is non-aromatic compound. Cyclopentadienyl cation. How many two pi bonds are there? Number of pi electrons 4. 4n plus 2 is equals to 4. 4n is equals to 4 minus 2. Then 4n is equals to 2. N is equals to 2 by 4. That is 1 by 2. That is 0.5. Cannot be considered as a aromatic compound. Then apply the 4n rule is equals to 4n is equals to 4. N is equals to 4 by 4. That is n is equals to 1. It is a integer. Can be considered as a anti-aromatic compound. Next, cyclopentadienyl anion. Apply the 4n plus 2 rule. 4n plus 2 is equals to 6 pi electrons. 6 minus 2 is equals to 4. Then n is equals to 4 by 4. That is n is equals to 1. Then the compound is aromatic. Apply the 4n rule. 4n is equals to 6. N is equals to 6 by 4. That is n is equals to 1.5. Decimals cannot be considered as an anti-aromatic compound. Now, cyclopentadiene is a non-aromatic. Cyclopentadienyl cation is anti-aromatic. Cyclopentadienyl anion is aromatic in nature. Next, cycloheptatriene. So this is also contains sp3 hybridized carbon atom. So considered as a non-aromatic compound. Next, cycloheptatrienyl anion. Cycloheptatrienyl anion. Apply the 4n plus 2 rule. 4n plus 2 is equals to see 1, 2, 3. Nothing but 3 bonds, so 6 electrons. So we need to consider extra pair of electron because this also involved in resonance. Like that it is. Then total 8 electrons. 4n plus 2 is equals to 8. 8 minus 2 is equals to 6. Then 4n is equals to 6. N is equals to 6 by 4. That is 3 divided by 2. then the compound may not be considered as a aromatic compound. Then apply 4n rule. 4n is equals to 8, n is equals to 8 by 4, that is finally we will get n is equals to 2. The compound is anti-aromatic. Then cycloheptatrinyl cation. Cycloheptatrinyl cation. Apply the 4n plus 2 rule. 4n plus 2 is equals to only 3 bonds, pi bonds. Then 6 electrons. 6 minus 2 is equals to 4. N is equals to 4n is equals to 4. N is equals to 4 by 4. That is finally n is equals to 1. Then the compound is aromatic in nature. Next, cyclooctatetraene. Tetra means 4 bonds, double bonds will be there. Hence, we are calling as a tetraene. Now, 4n plus 2 rule is equals to number of pi electrons 8. Then 8 minus 2 is equals to 6. Then 4n is equals to 6. N is equals to 6 by 4. Then finally, n is equals to 3 divided by 2. We will get decimals value. Then the compound cannot be considered as a aromatic. 4n rule is equals to 8. N is equals to 8 by 4, that is finally we will get n is equals to 2. The compound showing the anti-aromatic property. But when it comes to the reality, the compound is non-aromatic in nature. Why it is non-aromatic in nature means we need to observe the structure, planarity of the cyclooctatetraene. See the compound, see this bond in the y direction, this bond downside bond is x direction. Again, this is in y direction. So the compound will be present in x and y direction. So it is non-planar compound. When the compound is non-planar, then it is considered as a non-aromatic. For the anti-aromaticity also, the compound should be in the planar form. So it is not a planar structure. Hence, the compound is a non-aromatic nature. Next, when comes to the annulenes, naphthalene is a aromatic because we will apply the 4n plus 2 rule. Number of pi electrons is 5, then 10 pi electrons are there. Number of bonds are 5, then the total 10 pi electrons. So 4n is equals to 10 minus 2, that is 8. 4n is equals to 8. N is equals to 8 by 4, that is finally n is equals to 2. The compound is aromatic. But 10 annulenes, 10 nothing but 10 pi electrons are there. Hence we can call it 10 annulenes. 4n plus 2 is equals to 10. 4n is equals to 10 minus 2, that is 8. 4n is equals to 8. N is equals to 8 by 4. That is finally we are getting n is equals to 2. The compound is aromatic. But in reality, the compound is not a aromatic. I will tell. Next, apply the 4n rule. 4n is equals to 10. 4n is equals to 10 by 4. That is 2.5. This is anti-aromatic. The compound is cannot consider it as a anti-aromatic compound. That's fine. But the compound is showing the aromatic property. But in reality, the compound is non-aromatic. Why means here two hydrogens are there. These two hydrogens are in y and z plane. These two hydrogens are in y and z plane. Hence, the compound is not a planar. Because of no planarity, the compound can be considered as a non-aromatic compound. Next, 14 annulenes. 14 nothing but 14 pi electrons will be there. 4n plus 2 is equals to 14. 4n is equals to 14 minus 2, that is 12. 4n is equals to 12. N is equals to 12 divided by 4, that is n equals to 3. Then the compound is 14 annuline is aromatic. So 4n rule we can apply. 4n is equals to 14. 4n is equals to 14 divided by 4. Then n is equals to 3.5. So cannot be considered as a anti-aromatic compound. So the 14 annulenes are aromatic nature. 16 nothing but 16 pi electrons are there. 16 annulenes nothing but 16 pi electrons. Then 4n is equals to 16 minus 2, that is 14. Then 4n is equals to 14. Then finally we will get n is equals to 3.5 in decimals. So not be considered as a aromatic compound. Then apply the 4n rule. 4n is equals to 16, 4n is equals to 16 divided by 4. Finally, we are getting n is equals to 4. And then the compound is anti-aromatic. 16 annulenes are anti-aromatic, 14 annulenes are aromatic. Next, 18 annulenes. 4n plus 2 is equals to 18. Then we will get 18 minus 2, 16. 4n is equals to 16. N is equals to 16 divided by 4. Then n is equals to 4. When the when we people are getting n is equals to 4, the compound is aromatic. 18 annulenes are aromatic in nature. When we people are applying 4n rule, then n is equals to 4.5 we will get. Then the compound is not being considered as a anti-aromatic compound. So this is about the basic concepts involved in the aromaticity and aromaticity of different compounds we have discussed now. So these are the things for the practicing session. So thank you.